started recording. Alright, so okay, what is going to happen today? We will create a mod from scratch and go into the details step by step. And as I've said before, the development part will be posted on YouTube. So for our viewers there, this is being done with Unreal Engine version 5.4. But since you can be someone from the future, please pay attention to the developments in our Discord community, because all of this stuff is quite prone to change. But the basic logic, the fundamentals of the development should be the same, and you should be able to use this as a like useful source for your development and for modding. And how are we going to proceed? We'll first create this very bare minimum mod. So we will talk about some rules you have to abide by for your mod to function properly, for some compulsory classes that you will have to create to make your mod function. And then we will move on to creating a simple level. I think this is one of the functionalities that has drawn the most attention, to be able to create your own environments. So we will be creating a very simple one. So given our time limitations, we just have to go with a simple version of an environment, and in doing so we will also go through the material stuff. So for those of you who have been following this process from the beginning, we have had some issues with materials and their implementations. So I think we have finally come up with a solution that will allow you to create mods without issues, but you will have to follow some rules and use a material library created especially for this purpose to be able to do that. If you are using a Epic version, like a commonly distributed version of Unreal Engine, on the other hand, it's also possible to use a Metas fork of Unreal Engine, and if you do so, there will be no limitations, but I will get into the more details as we move along. So I just don't want to complicate it before we start. And yeah, and then after we add a level, we will add some UI. So your mod may also include some complex functionality, and this you might have to use some UI to manage enabling, disabling. For example, if you were to create a mod which has like a minigame, you will have to then find a way to start and stop the minigame, remove it from the map, and maybe bring it back. And having a useful, like nice UI is the way to do it. And then we will create a custom drum of our own, and I think this is also one of the subjects that will be that has drawn a lot of attention, and you will be motivated to maybe indulge into. So yeah, let's start off by naming what is compulsory and how a mod. So just before starting off, sorry, one last thing. If you have any questions regarding like future possibilities and some reinterpretations of what I'm explaining, then I would really appreciate it if you can lead them to the Q&A part. But if what I'm telling you, if what I'm explaining becomes completely meaningless because of something you don't understand, then you can just ask for, you can just type it, and I will see it and attend to the question. So we are not that crowded, so I think we can manage it. But yeah, I think this will be the most effective way to move forward, and also it will be better for our like future viewers on YouTube to follow along if there's no intermittency, or there's as little intermittency as possible. So yeah, first of all, welcome again, and let's go. Okay, so this is our mod project. This is called Paradiddle Workshop. On the YouTube video, we will leave a link to the GitHub repository you can clone to get access to the project. If you have already been following along, I think many of you already have access to this project. This project has been created with Unreal Engine 5.4, and it is also compatible with the Metafork version of the same version of Unreal Engine 5.4. So there are two ways to get access and use this project. And yeah, what we do basically in a mod is to create a directory which contains all of the assets that are required for a mod to run properly. And then we tell Unreal Engine to package all these assets together so that they don't get lost, so all the references function properly, and your mod doesn't crash. Unfortunately, some crashes were experienced, but that was on us. For now, everything should be good to go if you create the mod following the rules, and you should be good to go. And so the first rule is to have everything you need and you use in the same directory. What I mean by that is, for example, consider the test mod we have included in the workshop project as an example. Everything the test mod uses, every asset, every mesh, every material, like there are meshes here, materials here, every material, they're all located in this game/test mode directory. The exception to this rule is the engine assets. For example, if you were to access some basic mesh that is contained in the engine, then you are able to do it without creating a copy in your directory. What I mean by that is, I can demonstrate it. What I mean by that is, like, let's just open this class, for example, and take this mesh, and there you see like a cylinder, and if you follow this path to the cylinder, then you see that is located in the engine rather than the mod directory itself. That is true, yeah. So everything that is being referenced except the engine assets should be located in the mod directory, but you can reference engine assets in your classes, and they won't cause any issues. That's why we are using the same engine version on both sides. Actually, that's the reason behind it, so that those references don't get messed up. So that is the first rule. So let's start off by creating our mod from scratch. So the first thing we do, as we've just mentioned, we will create a new directory. Okay, the engine is not catching up with me. Okay, we will create a new directory and name this demo mod. So the name of our mod will be demo mod. By the way, all of these basic assets that you need, that are absolutely required for a mod to function, are already given in this my mod directory. So you could just rename this or use it as my mod to create your own mod without creating all these basic stuff. But in this session, I just wanted to go over it so that you get a better understanding of what is going on and how you can create those stuff on your own. So the first thing we do is, you remember I mentioned a couple of minutes ago that we tell Unreal Engine to package everything in that directory into the same PUC file, and by PUC file I mean Unreal Engine's file system to use that is used to contain Unreal Engine assets. So that is called a PUC file. Unreal Engine uses those to contain assets and load them from those files. And how do we tell Unreal Engine to do this? Basically, how does it understand that all the assets within that directory should be packaged in the same PUC file? We do that by creating a data asset label, and it is created by doing a right click. So this right click in asset panel introduces this menu from which you can select what you would like to create. So this is the content browser of the Unreal Engine. I'm also trying to very briefly mention these basics for those of you that are not familiar with them. So this content window is like a file browser on your Windows operating system. It's very similar. That shows the contents of our project. So we are in our mod directory that we have just created, and when we right click in the content browser, we are introduced to this drop down menu, and we can select what we would like to create. So here, this part is a bit memorizing. I'm sorry about that. So it's the logic behind it is a bit complicated. I don't want to go into that, but what we should do is to create a data asset, and from here you go primary asset label. Okay, and name this demo mode asset label. This is not compulsory, the naming convention, but it will help you to manage it if you name it properly. So once you go inside this, you are faced with some options, and one of those options is chunk ID. So this is the most crucial one. This tells Unreal Engine which ID to use when packaging assets. And this could be any integer, but because of the structure of this project, some integers are already taken, so you could reference the README file in the GitHub repository to see which IDs to not use, but basically they are 0 because it's the basic ID used by every other asset. It is, as far as I can remember, 10, right? Yeah, 10 used by the test mode we have included in the project, and I guess 11 for the my mod. So you should use anything other than 0, 10, or 11. Let's go with 12, and our assets will be ID'd with chunk ID 12, meaning that all assets that carry this label will be packaged together. And another crucial setting comes into the stage at this point. It is label assets in my directory option. So this should also be checked. This tells this asset label to label everything, every asset in that directory with that chunk ID. So this is very crucial. And we save it. And also the cook rule. So Unreal Engine has to process assets before making them available for a packaged build to use. So that process is called cooking, and it is sometimes not compulsory for some assets to be cooked, and sometimes it is. So Unreal Engine has a system of determining which assets to cook or not, but the nature of this modding project is a bit unconventional when it comes to compliance with Unreal Engine's automatic systems. So it is very strongly recommended to choose always cook option to be sure that all your assets get properly packaged. So this is done. So we're done with this. We are now sure that everything under this directory will be included in our latest package. So another class that we need to create that is compulsory is the manager actor. So it is a actor class. So how you access to those classes is through creating a blueprint class and select all classes to load it and go mod manager actor. So this mod manager actor is a class that we have created for you guys to use to manage your mod, and it is also used as a hook by the Paradiddle app to know that your mod exists and to basically initiate the mod once we load it. So we look for your mod content in the folders. So let's just take a look in the folder structure. So it is sorry about this. Oop. Okay. So it is. We look for your mods in these mod directories, right? Once we try to load them, and when we find them, we list them in the main menu, in the handheld menu in Paradiddle. But once you enable them, then what should happen? How do we know and how can we initiate a mod? How do we get things started? And that is through this mod manager actor I've been mentioning. So you create an child class of it, and the naming convention here is very important because Paradiddle needs to know a way to find this manager actor and access it. So it should be the name of your mod, demo mod, and then manager actor, and also the uppercase, lowercase is significant. So this is demo mod manager actor. Once you created this, the bare minimum for the mod is satisfied. So this is now actually a functioning mod with zero content. Of course, that's the problem. But it could be loaded and it could be instantiated with only two assets that we have just created. So what is the third one we see here? So that is a data set that helps you contain and organize your mod's content, which is not compulsory. But if you would like to create a mod that is especially a bit complex and has like different features together, such as custom classes, highway overrides, games, and maps all together with like a very sophisticated UI, then this will be really helpful for you to manage those functionalities. But it's not compulsory. You can opt out of it if you like. But yeah. So I think we've gone over the basics, and now we have created the essentials. Then we can maybe create this bare minimum mod. Okay, now we will create this bare minimum mod, and for that, of course, yeah, it is definitely like the main hub of yeah, okay. So we received a question asking if the assets you've just mentioned, the data asset, acts like a main hub, could act like a main hub for the mod to manage the mod content. You could use it like it, and in fact there is like an implementation of it in the test mod. If you want to like observe it in detail, we do utilize it in the test mod. Going back to it, now we need some assets, and the way to add assets is through this add and import. So if you have the directory open here, when you import an asset, it will import it directly to your directory that is open here. You can also drag and drop Unreal Engine assets and move them within directories, but there are some things called referencers and redirectors that sometimes mess things up. It's really could get messy, so I really advise to pay attention to where you're importing so that you don't run into a lot of trouble afterwards. So yeah, you can just import, and I think I've created a yeah, I've already okay. Okay, these are some assets that we will be using today. So we can just organize this a little bit, and I can just this will be a quick uh, mentioning of basic Unreal Engine as like management stuff. So you can just create a new folder here and uh, store your meshes. So this is not like a rule or something, but it's quite useful to tidy up the environment when you have the chance. Yeah. And so these materials, so these are default materials created by Unreal Engine. So if you are using Metaphor version, you can work with those. But today we will try to use the material library we have created, and this is kind of compulsory for people who use the default version of Unreal Engine distributed by Epic Games. So I will just delete those for now. You can just force delete them and create our own materials in the process. And we have textures, and let's just move those textures here. Okay, and there's like a save all option here. That so you see those little asterisks here, those little stars, that those indicate that those assets have not been saved yet. So if something were to happen to the engine, if it crashes or something, those might get lost. So it's not significant at this point, but believe me, Unreal Engine sometimes crashes without a lot of explanation, and you could lose some important stuff. So I really recommend using this every once in a while. As you see, they're all gone now, and we have all our meshes. And yeah, so let's take a look at this manager actor. So what I've pointed out before was that this was used by Paradiddle as a hook to your mod. So Paradiddle will find this actor, spawn it, and then uh, initiate your mod through calling a function within this actor. And what is that function? That function is called init mod from main. So this from main part will indicate, so you will encounter this convention, like this naming convention throughout the project. This from main part indicates that this function is called by the main app to do something in your mod. So this init mod from main function basically initializes your mod. And in doing so, Paradiddle gives two arguments. One is the pawn actor. Pawn actor means that the game object that represents the player. So just imagine playing Paradiddle and you are sitting in front of the map. So your existence, the headset, your controllers, and your existence as a player is represented by a pawn. For those who are a bit seasoned in Unreal Engine and game development, might find this explanation a little bit incorrect or a little bit too simplified, but it is basically that. So, from a more technical perspective, it is a game object and an instance of a class that handles player representation and functionality. Uh, so Paradiddle will pass that through so that you can use it to manage stuff with your mod. We will just do it in a minute. And the other argument passed through by this function is the UI collision channel. So what is a collision channel? Collisions are what comprise a system that is used by the game engine to handle interactions between game objects. For example, what makes a ball bounce on the floor in a game? So how does the game engine know that there is a ball has hit the floor and should bounce back? So those are all handled through collisions. So why, I don't know why I didn't give this example. How do you hit a drum in a game? I don't know why I just started talking about balls and floors, but yeah, the way you hit a drum, the way you grab a drum, uh, and the way you just drag it, drop it, resize it, they are all handled through collisions. So what is the UI collision channel? So not every collision, not every object has to interact with each other. So sometimes an object needs to ignore another, and sometimes they don't. So how do we define it? Those are defined through channels, and each channel has an attitude towards another channel. So for example, the drum channel blocks the stick channel. Those channel names are arbitrary. I'm just using a simplified version, but that's the idea behind it. So this UI collision channel is the laser in the app that you should be familiar with, right? So what is it for? So why is it important for us? So if we were to have UI, for example, in our mod, then the any UI button, any UI drop down should definitely block this channel, so that when the laser hovers over to that button and then you conduct the trigger, then we will be able to press the button. So those are the two arguments that are introduced by this initialization function. So for now, we'll just use the position of the pawn actor, but first let's create something that exists in our bare minimum mod. So what can we create? Let's see, what have we imported. So we have imported a lovely Christmas tree. What a coincidence, as if I haven't selected those before. So let's see what this Christmas tree looks like. So this is a mesh, right? It comprises of vertices, vertex, and Unreal. Then we have already imported this into Unreal Engine, and it is located in our demo mod directory. So everything is going as planned. So I just wanted to highlight that rule. What this mesh is lacking is, as you can see, a material. So yeah, Unreal Engine automatically assigns this world grid material if it's unable to find anything to fit this mesh. But as you can see, it doesn't look really good. Another thing is that this mesh on its own cannot be spawned to the map. Like you could place it, but right after you place it, you see that it's represented as a static mesh actor rather than a mesh. So what does this actor mean? So actors are basically game objects in Unreal Engine. So if you're coming from like Unity, you should be familiar with game objects. If you are if you're not familiar with any, they're basically physical representations of objects that can exist in a map. And the base object, not physical representation, but anything that can exist, that can be spawned into the world that we are that we create. So they are actors. The actor is the base class of that, and there are many child classes such as static mesh actors you see here. So in order to create this Christmas tree, in order to spawn it in our mod, then we have to create a simple actor. And let's just not mess our tidiness and create a new folder and say actors here, and go create a Christmas. Okay, this will be a default actor class. Sorry about that. I just got confused a little bit. Christmas tree actor. You could name this whatever you like. From this point on, there are no naming conventions. Of course, there are some naming conventions that are recommended by Unreal Engine. If you would like to learn more about it, just feel free to go through Unreal Engine documentation. For modding, for like creating these plugins, I don't think they play such a crucial role. But if you're into game development, if you want to do other stuff, I would definitely recommend taking a look at those. And yeah, we just created our Christmas tree actor, and once we open the the editor window for this actor, you just double click to open it. We are faced with this scene. So this is the physical representation part of the actor. So it's not compulsory for every actor to have a physical representation, but they can have it. So we can create something. And we will do it. So how do we add stuff to actors? That is through components. So we create components to add like physical representations, more functionality, and interaction with other APIs, etc., etc. So a lot of things can be achieved through components. You see, when I click this add button, we are faced with this huge drop down, and there are many things you can do to create an actor and add functionality through components. And what we will do is we will add a static mesh component. So a static mesh is a mesh whose vertices don't change position with respect to the root of the mesh through the session. So on the opposite, we have like skeletal mesh, which has like an animation, right? So anything that animates, some characters you see in games, they are skeletal meshes. There are also some exceptions there, but those are too much detail, so you could just assume that they are all skeletal meshes if they're animating, and they are all static meshes if they're not. This is not a rule that without exceptions, but yeah, this is a very simplified version of it. So we have created a static mesh component and named it, but we still don't see anything. But when we click on it, we are faced with this menu here that gives us details on how to create this static mesh. And here we see the actual mesh reference to be used for this component, and for now it is set to none. And let's see if we can find a Christmas tree here, and oh, now we have it. So okay, we have already created our static mesh component, and now we have it in our actor. And as I've pointed out before, this is still lacking is the materials. And now we have come to to a subject that is a bit complicated, and that is also a bit new to Unreal Engine users, but because it's peculiar to Paradiddle modding, and we will go over it right now. So normally, if we had no limitations, what we would do would to create this material here and name it anything, and then sorry about this. Maybe assign it like a base color. I'm just trying to do this very quickly so that we don't lose a lot of time, and then assign it to the tree, and there you go. You would have a tree that is red. But unfortunately, due to incompliances between the Epic's distribution of Unreal Engine 5.4 and the version we use to create Paradiddle, we can't do that. But to help you guys out, we have created this material library you can find in this workshop directory here. So when you open this, you can find this materials directory here, and then there are these base materials that we have created for you. Unfortunately, you're not allowed to edit those because these should stay the same for us to be able to create their replicas in the main app in Paradiddle once we load your mod. But what you can do is to create instances of these materials. What I mean by a material instance is actually mod has explained. I don't know if I'm remembering it wrong, but someone explained it really well in the Discord as well. But material instance is basically I need to delete this. A static instance, like it's not changing. Static in some way, an instance of the material class that can be manipulated with some limitations. I know this is a bit confusing, but yeah, bear with me. We'll get there. So how we can create this material instance is quite similar to the material creation process, and you right-click, you're faced with this menu, and you select material instance here, and then you create this material instance and Christmas tree mat instance, you can name it. And okay, once you double click it, you see that we are now faced with another type of menu. So this is not the first editor window we faced when we created a material which had many nodes and material functionalities. This is somehow looks a bit more limited, and it expects a material to be selected as a parent as opposed to creating something from scratch. So what we do here is then we select one of the materials we have created for you in the material library as a parent material. So what I mean by that is we choose either opaque lit. So the naming was done in a way to be explanatory actually. So as you can deduce from the name, this should be selected for material instances that are meant to be lit and opaque. So there's no translucency. So for a window, it won't be compatible, for example. And what we mean by lit material is a material that gets affected by dynamic lighting. So, for example, if we were to have a purple light, a white lit material would look purple, right? Because it would reflect the purple color. But a white unlit material, so a material that has a dedicated emissive color but is not affected by dynamic lighting or static lighting, will look white regardless of the color of the lighting you use. So you might ask then why would anyone ever create an unlit material? This doesn't make any sense. It doesn't look appealing aesthetically in existence of like different lighting. Of course, when it comes to game development, the answer is most probably and almost always performance. So, for example, if you're going to create a lot of the same thing, especially if you're developing for mobile platforms such as Android, like if you want to play it on a standalone Quest version of it, then we would definitely recommend using unlit materials as much as possible. So we have opaque lit, opaque unlit, translucent lit, and translucent unlit. Translucent C is also very costly performance-wise. Just a side note here. That is also quite costly, and yeah, those are the basic options we have for the parent material. So for the Christmas tree, I think the most convenient way to go is to go opaque unlit, right? Yeah, okay. So here we have selected our parent material, and as soon as we did that, we got introduced to these new features. So these are the features we have created for you guys, so that you will be able to manipulate the material and create the one you need through manipulating an instance rather than creating a material from scratch. So this is the interface we are offering to you to create the material that is the most well suited for your mod. So what do we have here? So when we enable tint and change tint color, as you can see, there's we experience color changes, right? But when you look at it closer, you can still see these textures. So there's a texture here, and it doesn't go away when I change the tint color. So for that, we also create this texture weight parameter. So it's when you set this to 0, for example, there you go. For now, you all have what you see is just the tint color. And when you select it to 1, then the texture appears and it gets multiplied. So the color gets multiplied with the tint color, the texture color. So for the Christmas tree, we already have a texture atlas. So it's not something I have created, but it's like a Creative Commons 0. So it's a free asset that I found online for you guys for this demo. And a texture atlas is a bit maybe a complicated concept, but it basically holds every color that is required by this tree in this atlas form, and it has been mapped by the creators of this asset of the mesh to use the appropriate color at every vertex. So when I demonstrated it, it will be much more clear, and you will get the hang of it much more easily. So when I just turn this tint off and select this base color texture, and then select the holiday texture, and then save it, and then go to our actor, which I closed, Christmas tree actor, and then select our tree mesh, and then select the Christmas tree material instance, and also select this Christmas tree material instance. And when we go to the viewport, we are faced with, I don't know why this happened, but maybe I selected the, okay, no, is this the grayscale version? Oh, okay, I copied the wrong one, guys. Sorry about this. But yeah, okay, so I copied the wrong texture, but as you can see, many of the colors are what they should be. So the greens are mapped to gray. So this is a bit of a gloomy Christmas. But I think we get the point right now. So what we did here was to create a material instance using our parent materials, set the texture to be used in the material, and assign this created material instance to our mesh, and then see the results. So we are almost ready to create this mod. And so what is left for us to do is to spawn this actor once we initialize the mod. So just to recall what we have gone through a couple of 10-15 minutes ago, this function in your manager actor is used to initialize your mod. So what we receive from this function is the pawn actor, and what this pawn actor represents is the player itself. So what we can do with this pawn actor reference is to get actor location. So we want to spawn this Christmas tree. We want to have it in our map, but where should we spawn it? So it should be spawned. I think it's a good idea to spawn it in reference to the pawn actor, so the player. So for that, we get the location of this actor. So what you can do in Unreal Engine blueprints is that once you drag something and then start typing, so like get actor forward vector, you can just access these features and use them. So and you can hover over to the results to see what it returns. So as you can see, this function like get actor forward vector, as one would expect, this returns a vector. Also get actor location returns a vector, which is the XYZ coordinates of the location of the player in our virtual environment, right? So what we can do here is to take this vector, add to it a multiplied value of this forward vector, which means that I take the position of the player and I take the direction of its forward vector, and I just move a bit to distance the tree from the actor, like the player, so that it doesn't spawn on top of the player, right? So we multiply not with a vector. So if you just right click here and select this float value, so we could select the distance to be like 350, and yeah, and we can just use this. So we have the forward vector, actor location, and then we can just spawn actor from class. So this function, this is a very common function, spawn actor from class function, is used to, as the name suggests, spawn an actor in your world, in the virtual environment you have created. And the actor class to be spawned is, as you would guess, is the Christmas tree actor. Once you start writing it, it should appear. Okay. So it is expecting a spawn transform. Transform is a data asset, like a data type that includes the translation, the rotation, and the scale of an object. So it's not compulsory for it to belong to an object, but it's basically a data type that holds a value, a vector value for the location, a vector value for the rotation, and a vector value for the scale. So if you don't want to create the spawn like a transform from scratch, you can just right click on it and just split it, and then you see the components of it, the location, the rotation, and the scale. You don't have to deal with rotation and scale. It's okay for us. We just fill in the location part with the value we just calculated using the pound location and forward vector. And yeah, surprisingly, this should be it. So yeah, moment of truth. We'll see if this works. Uh, so this is the first time for me doing it while explaining it. So yeah, I apologize in advance if something goes wrong, but just let's give it a shot and see if it happens. Let me check the. Okay, oh, okay. We just created the material here, which is not ideal. Like, it won't break the mod, but you'll have to find it here every time you look at it. So yeah, we can just change it after we see it. So it has been almost an hour. Well, I really appreciate all of you being here. It's incredible that you are just showing interest, and I know this is taking a while, but this is our first result to see, so I think I hope that it will lift our spirits up a little bit. And what we do to create the mod is to click here at this platforms drop down menu and select Windows. So for Android developers, for standalone developers, I recommend going through the README file, both the Unreal Engine setup process and also the packaging process is a bit more intricate when it comes to Android. But for Windows it's quite straightforward, and today we will be focusing on PC VR Windows packaging because it's much more simpler to demo it here. So yeah, we'll just package this project and select the directory. This could be anywhere. So this is where I store the workshop builds and wait for it to package. But let me check something. I hope this is not rebuilding it. Oh, okay, so it's not responding right now. Okay. Okay. Let's select the project settings and see. So in the meanwhile, I can take a look at the questions and and see what I can address. Oh, okay. I think yeah, you're doing fine without me there. I don't know why this is not responding. But okay, let's go to the project settings and check full. Oh, okay, so this is going to take a while. Sorry about that. I hope it doesn't, but let's see. Okay, it's almost there in terms of build. I'll uncheck it after this. And so what happens, let me just summarize it. So when you have this full rebuild selected, it trashes everything that it has built before and then rebuilds the whole project. But it takes much longer. Sometimes it's more safer. So if you are suspecting like corrupt files and corrupt packages, it's safer to do it. Oh, it's complete. So okay, let me uncheck that before we move on so that we don't experience this every time we do it. So once it is packaged, it gets stored in the directory we have chosen, but we don't need that directory actually. What we need to do is to locate the project itself. So the project directory, go to saved, staged builds, Windows, workshop, content, pucks, and there you go. There you see our pack chunk 12, right? So this is our mod right now. Congratulations to us. We have created a very simple mod, and it looks like it got packaged because I see some size here. So what we do here is copy it and paste it to the mod directory. So the mod naming convention rules, let's just remember that for a moment. So the mods should be located in the directory where you store PDF files and custom songs, and under the directory named mods. Furthermore, the subdirectory that contains your mod content should bear the exact same name, with attention to the lowercase, uppercase letters with your mod. So in our case, it's demo mod, and within that, the puck file, the content file that Unreal Engine uses, should also have the same name, also with upper and lower case significant with your mod. So there we go. We have the demo mod and the moment of truth. I hope everyone is ready for this. Yeah, let's go. So then we should open this in 2D mode. Yeah, we hear the sound. Okay. So we got our menu, we go to loadout mods. Here we go, we have the demo mod, and okay, there you go. We have our Christmas tree spawning in front of us. So this is our basic, like the ultimate basic mod that you can create. This is the bare minimum, but we are there. We are there. Yeah, thank you, Emre. Thank you for the compliments. And huge, definitely. Yeah. Yeah. From there, it is easier than you would anticipate to move on, and I think we will have an easier time moving on and making this much more intricate, much more sophisticated. So let's just rename this so that we can just I will just share these after the session, and you can just rename them and use them and take a look at them. Demo map, we can just go with bare minimum, and these will be omitted. Like once I rename this will be ignored. So moving on, now we are going to create a level. I think this is the part where it starts to get more real, and I remember some of you guys trying to create like performance level with nothing on the map. So after this like 10 minutes, I think you will be good to go. You'll have no issues creating that like very basic level. And yeah, so let's go. So first let's create a new folder and name it levels, and within this directory let's create a new level. So Unreal Engine's environments maps are called levels. So I think it's maps in Unity, it's levels in Unreal Engine. Here's how we create one. Okay, let's name this demo mod level, and let's open it up. Okay, once you open a level, you are faced with absolutely nothing. So there, we don't have anything on the map right now, but we'll get there. So let's start by creating something to maybe have in our level. So what can we create? Let's see. We have like a couch here. So first of all, okay, once you place something in a level, and once you click on it, you see its transform here. So remember I was mentioning transform is like a data type that contains a location, rotation, and scale. So this dragging and dropping, sometimes the assets end up in weird locations, like very extreme locations. So I recommend just zeroing everything down first and then playing it around on your own manually. So one important thing to note down is that Paradiddle is X forward. So you will be facing this direction once you open the app. So this on the bottom you see the XI here, the XYZ, and Paradiddle is X forward. So it's positive X is the forward direction. So this is the way you will be looking. So this chair, and for the mod environments, for the mod levels, we are currently supporting only supporting 000 as the player location. So this is the exact location where the player will be once you load this level. Keep that in mind. So if I were to leave this chair here, for example, you would spawn inside this chair as a player. So what we can do is to move it, and then we moved it a bit too far, maybe like bring it here, and then like rotate it a little bit, and then maybe move it to the left, and it looks hideous without a material. So let's create another material, which should not be the case with a texture atlas, but I just want to go over the process once again properly, so that we just recall how to do it and create the material again. So I create a folder called materials. This is of course not compulsory, but it keeps it well organized. So within this materials directory, I create a material instance. Here it is, and name it main material instance for meshes. So these meshes, that this is a bit of an extra information, but these meshes that share a same texture atlas, so the meshes that share this same texture, being this texture in this case, can be handled through a single material, because basically they have the same material. But what the creator of these assets has done was to map every vertex here properly, so that every part of the mesh got painted properly, so to be said. So that's why we named our material to be a main material instance, and we open this material instance and then select, of course, in opaque unlit as our parent material again. Choose tint, not tint, sorry, base color texture. So the texture atlas we're going to use. Choose the holiday base texture and save it. So we now have our material instance is now ready. And we can now assign it to this chair. And when I write main, so when I assign it, so we end up with a gray chair with properly colored legs. Yeah, so in our map for now we only have a chair, so let's bring in something else so that at least it looks somehow like an environment. Let's bring in another mesh, let's bring in a rug. So bring this to 0, and so when I drag and drop, so let's do it in another way so that you see an alternative approach. So when I dragged and dropped the chair here and then assigned the material in that order, you see that the mesh in our directory, so the source of this asset in this level, did not get assigned any material. It still lacks any material. But when I change that order, like when I open this another mesh and assign the material here and then save it, then when I drag and drop it, every time it will get assigned the same material, so you don't have to assign it again and again. So let's have so for those who are more familiar with the the programming logic, when you assign it through here, the default class gets assigned it, and on the level you assign it to an instance. So yeah, we have like 3 rugs in our map. Let's make this one a bit larger so we get the chance to play around with scales as well. Let's delete this one, this is a bit extra, and this one as well. So yeah, we have like a huge rug, and yeah, let's make it like this. A chair, and then maybe larger. And yeah, I think for now this is enough. Yeah, it should be enough, right? We're just testing this out. So we now have our level. So another note, sorry. So some Paradiddle assets do use lit materials. By lit materials, I mean materials that interact with real light, change their colors depending on light. That's why, in order to properly use these assets, such as drums, so drums like the basic drums, the default drum class uses lit materials, you need to have a form of light in your map, and you can add this through here. And let's do that again. I click this plus drop down button, that says quickly add to project. I choose lights and skylight. Skylight is the easiest one to manage. All of the others have more intricate properties that you might need to adjust to have proper lighting. So for anyone who is a bit unfamiliar with this concept with lighting and who just want to go for a simple level, I would definitely recommend using a simple skylight and nothing more. Another important note is that the more lights you have, so we could change this to static, the more lights you have, the more costly it will be for the app to run, because the lighting and the shadow calculations get much more complicated basically. And so I would really pay attention to the number of light sources used. And static and stationary and movable lights, these pertain to how the lights create shadows and with what objects they interact with. I really don't want to get into those details at this moment. It's a bit too detailed, I think, for this session. But if you want the light to don't cost much, you can just go for a static light. But one thing is that our drums need a movable light for to exist, to work properly. So just leave one movable light, and then you can just use static if you want to create more stuff. So we'll create this skylight, and I think now we should be good to go. But how are we going to include this level in our mod? This is the next question that needs to get answered. So we have two ways of doing it actually. One is the simpler version, that is to make the make Paradiddle include this level in the menu. So this will appear along with the other levels you have in your menu, just like a normal level. And it is much more simpler to implement, and modders who don't want to indulge in especially UI creation, I think will be fond of that method, and I will now demonstrate that method. And the other version, the other method, is to use a function called load mod map. I can't recall where it was, but okay, here it is. So this directly loads the mod map, but to call this, you will need to have some form of UIs to control it, right? Because if it just loads it right after you instantiate the mod, it won't be appealing to the users, and it will maybe feel a bit too intrusive just right after you, if you do it right after you just load the mod. But this is the direct way to do it, and I will get into this mod communication subsystem. This is the most crucial part actually about the mod communication infrastructure we offer. But just as a side note, there's an alternative method where you can directly load your map, but now we will implement the first method I mentioned, which is to make the level get included with the Paradiddle levels we have in the default app. And we do this by creating okay, you can just so this is like the event graph, and as you can recall, we had this initialization function. Now we are taking a look at our manager actor, and you can just add your own events here, and let me do that again. I just right clicks, write custom event, and you're just faced with the option to add custom event. And then you can just rename it, and I will just rename it init mod with map addition. And I will just you can just alt click to break a link. So I think you've figured this out by now, but just to highlight it, these links control the execution flow, and the execution follows these links. So first this event gets called, then this function gets called, and if I were to add something here, then it would get called. So I'm sorry for not mentioning this before. Sometimes I just overlook these stuff, but yeah. I'm trying to keep an eye on the text to see if anyone got detached from these, but I think we are good for now. Okay, so I detached this, and I want to call init mod with map addition function from here. So now once we initialize the mod, this will be called. So let's fill this part. So what do we want to do? We want to make our map be included along with the other maps. So but how do we communicate this to the main app? Do we have this infrastructure? And the answer is yes. And the infrastructure is called Mod Communication Subsystem. So this subsystem, I really don't want to dive into too much detail and make this more complicated than it is, but subsystems are basically systems that you can access globally. So anyone who is a bit familiar with development might know that sometimes you need references to instances to access stuff, but these subsystems don't require that. You can just access them globally and call the function through them. And what this mod communication subsystem handles is almost the whole communication between your mod and the main Paradiddle app. So before we move on any further, I just want to take a quick look at what is possible and what some functions are that you can be used, and then move forward with our map mod. So here we have the mod communication subsystem, and I just can't recommend enough to read this through and see what is possible. But some examples are you can just load a map directly through this communication subsystem. You can add them up to the map list, which we will use. For spawning your custom drums, we will use this function. I doubt that we will have time for it today, but it's a really nice feature, and you will have to use this system to do it as well. And for some of your features, you might have to access the drums that exist in the level. So those drums might not be limited to the drums created by your mod. So for example, let's assume that you have created this mini game where you want to find the drums and spawn like monsters on them so that the players can hit them and basically kill them. You will have to get access to all the drums that exist in the environment, and not just the drums that are created through your mod. So this also allows you to, this communication subsystem allows you to do that. And another function of this communication subsystem is to allow you to know what is happening in the app. So you can subscribe to some event dispatchers, which I will go through and I will explain, to know what is going on in the main app during the session. So for example, if a drum is being hit, so I would like to change the color on the tree, the ornaments on the tree, depending on which drum has been hit last. So I subscribe to this drum hit event and then get access to that color and then change the color. So there goes an example. I want to spawn some monsters to bug you when the song gets created, just to mess around with the player, and I want to destroy them when the song gets finished. So I subscribe to song created and song finished, and also to song deleted events, and get information on those and then do stuff with that information. So just to create one of my infamous paint depictions that is beloved by my team members, but yeah, I think it will make it more clear. So let's assume this rectangle is your mod, right? And of course the purple rectangle is Paradiddle, and there are events happening. Oh, sorry about this. There are events happening within Paradiddle that are depicted with this blue. Drums are being hit, songs are being played, they are being deleted, high scores are being made, a lot of things, alright? Drums are being deleted, created, and there is this subsystem here, right? It's right in between, and it is the bridge. So this is the mod communication subsystem. So any function that you call to make requests, such as I want you to load my map to the environment now, and I want you to add my map to the map list. They are taken from you, and they're directed to the main app, and then the main app handles that. And all the other events that are happening in the main app, all these drum hits, songs, and etc., they have these event dispatchers that make the subsystem that let the subsystem know that they're happening, and these dispatchers live here in the subsystem, and they are being called consistently by the app once these events happen, right? Drum hits, song deletions, song creations, and you can subscribe to these. Let's use another color, I don't know. Subscribe to these and to react to those events. So this is basically the structure. And what we will do using this knowledge is to add mod map to map list. So once we call this function from the communication subsystem, if we were to take a look at this incredible paint once again, we are using a function to communicate to the main app that we want to load the level into the we want to add a level into the levels list. Okay, so it's asking for a map to add, and as you can see, we can't do anything with this variable, and we don't have this variable. And what you can do in these cases most of the time is to right click on it and select promote the variable and name it like demo map to add, and then you have it. And once you compile this, click here to compile this blueprint class, then this default value option pops up here, and then you can select. Unfortunately, we already have a demo map, so don't confuse it with this. What we have created is this demo mod level. Okay, so we selected. It's asking for a mod manager actor to associate it with. So we are already calling this function through a mod manager actor, and blueprints have this reference, which gives you a reference to self. So anybody that is familiar with C++, I think will know it, like this word will mean a reference to this self. And this is the mod manager actor, and then you are asked to give a name to the map, which we can name demo mod map. This will appear in the menu, so you could leave it empty, so it's mostly for the user interface, and also the map icon. So you can select an icon, but remember the asset rule we mentioned right in the beginning, that you should not reference any assets that are outside of your mod directory other than engine assets, right? So for example, if I were to choose like an asset from the test mod, from the other mod, this would cause a crash because it will not be able to find it. So for the time being, I think we have like this holiday assets, these textures we use for the material, I think they will do fine, right? Let's just select them. And if you are not sure of the path to the asset and want to check it for your see it for yourself, you can just hover on it and it tells you where it is. So for example, it's in game demo mod textures, so it is within our scope. So this should be safe to do it, safe to do. So yeah, this is it for the map actually. So I think we should be good to go. First, I just want to delete this. Sorry about this. Delete the. Oh, sorry. Workshop builds. Windows. Delete the contents of this so they doesn't cause problems. And then we will repeat the package process once again. Repeat it. This should take much shorter, I'm hoping. Yeah, it's almost done. Yeah. Okay, so remember this directory. Let's just go over it once again. It is the directory of your project. Saved, stage builds, Windows, Paradiddle workshop, content, pucks, and the puck name you just created. So, oh, did we connect to the functions? Yeah, okay, alright, sure, cool. Let's just copy that puck file to, let's select it again, copy it to here, demo mod, and rename it properly to be demo mod, and let's see what happens. Okay, another demo. Hit play. Let's open it in 2D mode. Okay. We have mods. Let's enable our mods. See, nothing happens. The Christmas tree didn't appear, but let's see if the map got added, and it's here. So once you click it, it loads up. So for the 2D mod, unfortunately for the moment we don't support this custom mod map feature. As you can see, the menu got messed up, the player position got messed up, but you can see that lovely chair we have positioned and the mat, and the chair is also hovering in the air, so there's a little bug there. Of course it's like misplacement, but yeah, this is it. There we have it. So yeah, we have the map, and another step towards creating beautiful mods. So I think this was also successful, so we can move on. And another feature we wanted to offer you guys, it was to be able to make HTTP calls, like calls to the servers you're maintaining. So the purpose behind that is to enable you to feed in information to the mod live, like if you were to maintain a server, for example, that retains information pertaining to the creation of the level, that would define how, for example, how the stuff gets placed depending on the weather, and you create functions that do that, that retrieve this weather information and create stuff accordingly. Another more realistic approach would be to create custom leaderboards and custom lists. Maybe people can load and see and benefit from. So to do that, we've added a plugin to the both to the workshop project and to the main app that you can use quite easily to make calls. But I just want a second to get access to that, because I think I lost the access to the link. Yeah, I will just find it in a second and create it. So in the meanwhile, we can just create another actor that would carry this feature and make it available. Let's create another blueprint class, another actor, and we could call this HTTP demo actor, right? And within this actor, we can just create a basic static mesh. This could be a background mesh. So to make what we will do is that we will retrieve some information from a server, and you'll just log it to add like a text object in our level, and this is the background for the text to be more visible. So it's a very plain mesh, basically a cube. So Unreal Engine has a lot of these basic meshes within itself, so you don't have to find or create them using 3D software. So the one thing that you have to pay attention to is, of course, the paths to the object. So when I just hover over this, on the top you can just see the path to this object is engine basic shapes. So it's quite safe to use. So I just use it. So as we pointed out before, Paradiddle is X front. So we will be looking in this direction. So this is how we are going to see this board. So I just want to make it a little bit bigger. Oh, I just made it bigger in the wrong axis. So just okay. Then make it look like a board, and yeah, maybe extend this a little bit more. And let's just give it a plain color. So to give it a plain color, we need to create another material. So let's do that. So let's go to materials. Just another note. So if you're using the metaphor Unreal Engine, you can just go ahead and create your materials. For those who just forgot about it or just didn't catch the part I just mentioned it at the beginning. So, but with this version, we create the material instance and name it plain color material, and name the parent again. And now we don't need this texture. Actually, this texture makes it harder for the text to be visible. So what we do is that we enable the tint color, make it like a bit of a maybe color on which black would be usable, and then enable this texture weight option and drag this down to 0. Maybe make this a little bit darker, right? Yeah, let's go for the purple. Okay, as you guys wish. Yeah, sorry about that. You're right. That's not very patriotic. I will go for a purple. Yeah, this will be our plain color. So keep in mind that these values, like the tint value, can be changed at runtime. So if you were to assign this material to a mesh, for example, I am spawning a snowball every time a drum gets hit, but the snowball has to carry the color of the drum, a matching color, and I might not get the chance to demonstrate it. That's why I'm just giving this example, but if I get the chance, I will definitely do it. So it's an important part of this material infrastructure, I can say. So when I assign this material to the snowball, I can change the tint color at runtime to match the color of the drum that is being hit. So you don't have to create a color every time you want to create another color. You don't have to create a material every time. Yeah, okay, I said it right. So, but for now, we just have this default tint color and created this plain color material. And let's assign it to our board. And yeah, there we have it. And let's create a text render component. So this actually, let's give it a rotation so it looks in the right direction. Oops, sorry. This component is not well fit for this job because the information we are going to receive is a bit long, and this component has quite a limited functionality. So if we were to do a more professional have a more professional approach, I would definitely recommend creating a proper UI widget. That's actually our next subject, so this session might get a bit prolonged, but yeah, we'll see. But for now, for the sake of doing it as quickly as possible, let's just go with this. And yeah, let me get access to okay, so I just created a copy of it, so yeah, a bit cheating to do, but yeah, I just forgot the link. Sorry about that, guys. And let me see. Okay, so we now have our board. We now have our text render component. Let's add the functionality. So with every actor, you get these three basic functionality appear in your event graph right after you created it. But as this indicates, they don't get called unless you enable them. So what begin play means, so as the name suggests, is that this gets called when the actor gets created for the first time, and it's called only once when the actor gets created. And this overlap has to do with collisions. So this might never get called if you don't enable collisions, if you don't have anything to collide with. For example, for this actor, it won't. And the tick function is the update function. So for those who are familiar with game development, this is the function that gets called every frame. And it carries the frame, like the delta time between the frames. It's a very costly, so I'm a bit diverting from the subject, but it's a very costly function to encumber with complex functionality. So I would recommend using this with caution. I wouldn't recommend, for example, checking very complex stuff in the tick function, or accessing too many things within the tick function if you were to use it at any time. But for now, begin play will do fine. So let's go ahead and use one of the functions that we had we have talked about a moment ago through mod communication subsystem. As I've already pointed out in the painting, there are some events going on in the main app which invoke some dispatchers, and by listening to those dispatchers you can implement your own functionality that reacts to those events, right? So let's see. Let's bind event to drum hit. So this event will get called every time a drum gets hit, regardless of what type of a drum it is. It could be a drum created through your mod. It could be a default Paradiddle drum. Also, one side note, drum word is used for all the instruments in Paradiddle. So that is something that has changed over time. We now have other percussions, but they're all drums, basically. So what we just call this bind function. Now we have to create this event, and when you drag and drop this, you can just create this custom event and name it on drum hit event. So this brings you. Oh, okay, so I think we can also. Oh, see. Okay, we can just manipulate the color as well. Okay, this gives you a struct. Structs are a type of data types, I can say, that can contain different kinds of data types, basically, to simplify it. And the data it gives you has a reference to the actor, to the drum actor that has been hit. So this, as you can recall, is the game object reference, which has like position, rotation to it. So if you were to, for example, spawn a monster on the hit drum or something on the hit drum, you could just get actor location here and then spawn it there, right? So it has a hit velocity, so you can just make things jump depending on the velocity, the magnitude of the velocity. There's the hit location, so the exact location of the hit. So it can also be used to spawn something. So the drum location, for example, refers to the center of the drum, but it's not always where you hit, right? And it also has a boolean called is right hand. So if this is false, the hit has been made with the left hand, and it's true. If it's true, it has been made with the right hand. So what we are going to do for now, we're not going to use anything but just the color. So let's just create a. So what I did was to create a new variable. Sorry, sometimes I just get lost and do things quite fast. So I create a new variable by clicking this plus sign here, and it defaults to a boolean type, which is not the one we need. So once you click on it, you can just use this drop down to set it to linear color and just compile it. And you can just rename this to hit drum color, right? Okay, so we can just set this to be not okay. So and then we can just use the HTTP function, which I got lost right now, but yeah. P request, was it this one? No, it's not this one. Sorry about this. Okay, yeah. Okay, yeah. Okay, I just copy pasted, but let's find it together so that I'm looking for the plugin. I wonder if it got p make request header. Post request. Okay, yeah, it's this one. Sorry for the confusion. So it is, once you start writing HTTP, it's this post request. It's the plugin we have enabled for you to use to make these requests. So once you select it, then you have to select the type to get, and then it will turn into this same request node. And this HTTP request will retrieve a fact about cats every time you send it. So it's quite nice. And but of course there is a possibility that it fails. So in case it fails, we have to do something with it, right? We have to let the user know that it has failed. So how can we do it? So we already have this text here. So we can also change the default to you are now. You can learn about cats by hitting drums, right? So this is the basic message. So we can just decrease the scale a little bit, right? Oh, what happened? Oh, sorry, this deserialization got it messed up. Let's just, maybe the copy paste didn't work that well, so let's just delete this and use this instead, the ones we just created. So let's just do it from scratch to just avoid any confusion. Just I will just cut this link and delete this. Okay, I'm creating this post request. I'm selecting getter, and yeah. Okay, so we are now making this request. So if it's not successful, what should we do? We should then let the user know. How can we do that? We can change the text in the text render component. So I just drag and drop it, and I have a reference to it, and when I create a node from it and say set text, it gives me an option to set the text of the text render component, and I can just create another node from this and make literal text. So it will allow me to write something here for the users to see. And if it's not successful, we can tell the users that the cat has run away, right? So it's not successful. But if it is successful, so this will return a JSON from us, and okay. We have a function called load JSON from string, which takes in a string and creates a JSON out of it. So JSONs are a very simplified definition would be a file format that has like these fields you can access, and this URL we are using will return a response containing a JSON file, and through Unreal Engine's built-in functionality we can create a actual JSON from this response and access its fields. So this will be our JSON string, and this is what happens when it's successful. And this JSON object will now have fields, and we can access these fields by calling getField functions, right? And the field name for this will be fact, but this is very hard coded, so I know this what this URL returns, and That is why I'm using this field name. By no means this is like a default application. It's very peculiar for this URL we are using. And we will get the field field name, and we will just make, so Unreal Engine right now does not know what this fact field returns, so we don't know the data type. But since I already know about this URL and what this returns, I know that this is a string field, so I can use this function, make literal string function, and use this value to make a string out of it, and use this again to set the text render component, right? So this will happen every time we hit a drum. A request will be sent to this URL, and the cat fact will appear if it's successful on this demo actor, on this text render component, right? But of course this is a transient process, so it doesn't, so transient processes are depicted with this clock symbol. It means that this doesn't happen at the same time. So this part of the flow does not happen right after this, but there's something to be that is waited for in between. They're not simultaneous. So if you were to bind some functionality to this, you might have to, add some precautions that, for example, a drum doesn't get hit again before we receive this information. Let's do that. So let's say that let's create a boolean like block function. Okay, and let's set this to true here, and let's set this to false here. Okay, so it will just lift the block once it's complete. Okay, and this is like a way to handle, I don't know why I dived into this, sorry if this is a bit boring, but yeah, it's just so, and right here you can just say that if this is false, you can just enter it. Okay, yeah. So how this will flow is that it will check this boolean. If it is false, it will continue. Then it will set it to true. And if I hit the drum before it reaches here, then it will go here, and then it won't move on further because this is true. But if when the request is handled, either by failure or success, it will be set to false again, and then this will become enabled again. So if you can recall, we just also saved this drum color value to use it to set a feature in our materials to change the background color based on the drum color we are using, right? So how can we do that? We get the drum color from this event. It is contained here, and if you can recall, we have a tint feature in the material that can be manipulated at runtime, as I've pointed out before, right? So this is what we're going to do. But to do that, there's another thing we have to enable, and that is that we have to create actually. That is a dynamic material instance. So a material instance is a static instance of a material, and a dynamic material instance is a an instance that can be manipulated at runtime. So what we're going to do that is to get the material of this text this is wrong. Get the material of this mesh. So the mesh carries the material that we have created. So to access that, we can just get material, and it is asking for an index. So meshes can carry multiple materials, they can contain multiple materials, and those materials could be applied to different vertices, but in many cases a single material would be sufficient, and like leaving this index at 0 will get you that material. And we now received access to a reference to the material of this mesh, and from this we can create dynamic material instance. So this will be our parent material, okay, and this returned value will be a dynamic instance, and I can just promote this to a variable and say dynamic mesh mat here and set it, okay. And then this is going to look a bit weird, but it's a sound way to do it. We can just set the material of this mesh here, okay. And then once a drum gets hit and we receive the color matching color, we can then get this dynamic mesh material, which I didn't name properly, and set vector parameter value. So a color is basically a vector that is represented by RGB values. So to access this material variable, we use the set vector parameter value function, and the material name, parameter name is tint, and you can see that here, right? And we can set that value there, and this hit drum color. So we didn't even have to save it, but yeah, doesn't really matter that much. So okay, we now have let's go over this very quickly. I know we are over time, but I'm all good right now. So after this topic, I just want to ask the attendees about how they feel and what do you think, what they think that we should do. But I just want to wrap this up because we are almost there with this HTTP functionality and also this additional material functionality, which I believe are quite significant. And yeah, okay, we're almost there. So the only thing that is left is to place this actor. Place this actor into our level, right? So I want to just place it here, and have it here. Maybe enlarge it a little bit. So yeah, okay. It will just don't want it to disappear once we load it. I know this looks hideous, but it serves the purpose. So yeah. Okay, so what will happen now? So our actor is now included in our level. It means that it will get spawned automatically. So as you can remember, we called some spawn functions manually, right? Here, for example, spawn actor Christmas tree actor to spawn the Christmas tree actor in the beginning. But if you place an actor in a level and then load it, all those actors included in that level will get spawned automatically, and then their begin play functions will get called, right? So that is what's going to happen when we load this level, and we will then bind to this drum hit function, and if the function is not blocked, then it will enter this part, and then it will request a fact about cats, and it will print it on the text render component we have created. So yeah, another moment of truth. Let's go ahead and package it. Before that, let's delete the contents of the previous package, and yeah, let's go. So this is demo mode basic level. Yeah, it is taking a bit. Sometimes it becomes unresponsive, but yeah, I think it should be good in a moment. Let's see if we are missing anything else. We are waiting for the POC file to appear. Okay, yeah, it's complete. Alright, so we now have it here. It's 12. Remember the chunk ID we have assigned in the beginning. I just want to make some references to recall some stuff. So where were we? We were in okay, let's go documents, Paradiddle, mods, demo mod, have it here, and rename it to demo mod, and let's go. Okay, where's my Steam? I have it in 2D mode. Alright, so let's go. Have a mod, enable it, scene. Let's load our level. Nice placing. So let's okay. So we hit the snare, so it turns red, and you get a half of effect. So yeah, yeah, the text render component didn't function, so it's not, it doesn't warp automatically. So yeah, it's not the best choice, as I've already pointed out, but yeah, it serves the purpose, guys. So we have a cat fact. What was is K for? What's the key for kick? I forgot. Yeah. I don't know if you have any. Oh, let's spawn another drum. Maybe. Ah, okay. Yeah, okay. This also happens. So this, yeah. Yeah. Adjust two drums. It takes their color. So I'm hovering over like different drums. And it's like reacting to those. Oh yeah, sorry about that. Okay, so there we have it. So this part is also complete. So let's quickly go over what we have been through up until now, and then I can ask you guys if you want to continue this session, or if you would like to ask some questions and uh, do a part 2 in a couple of weeks. It may not be that soon, and work on your own a little bit. Uh, Depending on your answers, we can just do like another hour of this, or uh, do a quick Q&A session, and then schedule another one like in a couple of weeks or so. So a summary, a brief summary of what we have been through. First of all, before the summary, I really can't say enough how much I appreciate this, like sparing your time on a Sunday to follow this session. I'm sorry, I apologize if I have made some mistakes that made things unclear for you. I did my best to explain this stuff on a complexity level that is both clear, that makes things both clear but also not that confusing. Yeah, so what we have been through up until now. So we've learned the basics of modding, the rules to abide by, some naming conventions, and directory rules. Then we looked at the fundamental classes to create, and what they do and why they should exist. And we took a look at some optional applications using the data containers to manage your mod. Then we created a bare minimum mod with a Christmas tree just to show that it works. And by doing that, we also went over the new material library infrastructure, and how you can create material instances, and by manipulating them, how you can create materials that fit your needs. And then we created a very simple level, and we added it to the level list of the main app, and we loaded it by selecting it from the levels list through a environment loading button. And we learned a bit about how environments are created, and what are some rules that we need to follow to have like a proper environment that can be used. And then the last part was about creating an HTTP call and retrieving information from a server. But in addition to that, we also learned how to manipulate dynamic material instances and how to create those here. And that was it.